Hey everyone, Jason from Alvatone Audio back again today, and today I want to jump into multi-channel connectors with the DB-25 plug. The DB-25 is just one part in a series of parts that were designed for serial communication uses by the Canon company all the way back in the early 50s, and they get their name because of the D-like shape of the actual connector. So again, something that's not really developed originally for audio, developed more for computer systems or just other electronics uses. Now when I talk about the Canon company, that's Canon, C-A-N-N-O-N, with the two N's in it, which is currently a division of another larger company called ITT. Now Canon, they've actually been focused on connectors and wiring assemblies for lots and lots of various systems for I think 100 years now. And anytime you get into stuff like this, especially like the DB connectors, or if you get into the DL connectors, which we'll talk about another time, you're going to see Canon and ITT come up a lot. And a lot of technicians will say, oh, well, the Canon style pins or a Canon crimp tool or Canon/ITT compatible, whatever. So whenever you see something like that in a forum post or something like that, know that Canon, both ITT, or the companies that they're talking about that basically invented this stuff many, many years ago. Now, despite these DB-25s being, almost 70 years old now, they really haven't fallen out of favor with the audio community just because it's still a very easy, cheap way to get 8 channels of balanced audio in or out of an audio device, particularly modern sound cards, which just tend to be like one rack space. It tends to take up a lot more space and be a lot more expensive for the manufacturer if you want to do 8 individual XLR inputs or outputs. So these are a good choice because especially if you're not going to be using them, then you didn't pay for a whole bunch of jacks you didn't need. But it's very easy for a manufacturer to add a lot of I/O expandability by using these DB-25s. Now, if you go shopping for parts because you decide you want to make one of these, you're going to see that there's 2 main types out there. There's the soldered and there's the crimp style. I'm only going to do the soldered today. Not that there's anything wrong with crimp style, I'm just going to focus on this one part, especially because if you're just do DIY these at home and you only have to build 1 or 2, I think the soldered connector is a better choice for you. But I will take a minute and talk about the crimp style. If you look at the soldered, you can see that it's everything you need is there. The pins are already in it, and it has all the solder tabs on the back, and that's it. On the crimp style, and I have some pictures here, you can see that whenever you get the D-sub connector parts or the terminal blocks, they actually just have hollow. They have holes in them where you would insert the pins that you're going to just individually crimp onto the ends of all of your individual wires, as opposed to soldering the wires directly to the soldered versions of the D-sub connector. Now for pros and cons, on the solder connections, they're definitely going to be cheaper because you don't have to spend extra money for tools or the extra pins. But it does take a lot more time, skill, and patience to assemble. And I would say if you don't have a lot of experience soldering and you try to do one of these, it's going to be very frustrating for you because the tolerance is just very, very close on these. Additionally, if you ever happen, at least on the male side, to break one of these pins, you're pretty much going to have to trash the entire connector and start over, which means you have to cut. If you get 8 channels of audio, you have to cut all 24, get a new connector, and start over again because these are not replaceable. I mean, could you technically heat this up, push one of those pins out, and push a new one in? Yes, but I would never trust the connector after that. Now, the crimp style, the assembly is a lot easier because you don't have to do all this tight soldering work. You just crimp them on. And again, just because it's crimp, you can solder on a crimp pin. Having said that, it's still easier because you're just working on individual wires and not in this super tight jack density like this. But all the parts are more expensive. These connector types are still pretty cheap, but then you have to start buying the pins, which if you buy them individually is as much as one of these, or you have to buy bags of 100, which may be a lot more than you need. Almost all the pins I've ever seen are gold, which just makes them a little bit more expensive from a hardware standpoint. Plus you need to buy the crimp tool to make sure that you get the proper crimping force when you apply the pin onto your wire. Now, having said all that, I'll recommend this. If you just have to build a couple of these and you're decent with a soldering iron, then go ahead and try the soldered version. Take your time, do the best work you can, do a good job, and these will last you for years and years to come. If you have to build a lot of these, and I mean like maybe a dozen or more, then it may be worthwhile to look into the crimp style connectors. They're going to save you a lot of time over the assembly process, and even though it's more expensive, it's just not that much more to buy in. The crimp tool costs you around $40. The crimp style pins, they're almost always gold, so it's just a little bit more expensive from a hardware standpoint. But last time I checked, a bag of 100 cost about maybe $45, $50. So do the math, add it up, and see what it looks like. Now you still have to be really disciplined when you do use the crimp style. You have to make sure that you really crank that crimp tool down on every single pin because you don't want the pin to fall off the end of the wire, that kind of thing. Also, just because it's crimp doesn't mean you can't also solder it. After you crimp it, it's very easy to heat that up, just touch the end of a piece of solder to it, and it's going to soak it right up like a sponge, just to give you an additional extra bit of connectivity and make sure that pin's not going to come off. Okay, you can always do both, and I've done it on both crimp pins on this, and also DL connectors, which is another type of crimp versus solder connector you see a lot of discussion about. Lastly, if you're thinking about using these for live use, because I've seen a lot of people that build amp panels for live rigs or something like that and say, oh, I like the crimp ones because when they break on the road, they're easy to fix. I'd recommend that if you're using this for live use, then you just find another solution entirely. Just because even if you do a really good job and use the crimp pins and you get the best hardware you can, this is just not the most robust connector type out there. If you really need a super durable multi-channel solution for live use, I would look at some other manufacturers like Amphenol, Link, Syntax, and Whirlwind. They all offer great Super Duty, robust multi-channel stuff that's designed for live use, get banged around, that kind of thing. If you absolutely have to use one of these inside of a rack and you know you're going to be managing it yourself and it's just not going to get, mangled by someone else, then I guess you could probably get away with it. But if you really need something robust, then this is probably not my #1 choice of connector. So when you go shopping for parts, you're going to get everything a la carte. You're not just going to get one bag with all the parts in it typically. Start with the connectors. Have a female DB-25 and a male DB-25. For analog, you can pretty much just use just about anything, but you can also pass AES digital signals to these. Make sure that if you're going to use these for digital signals that you get one that's rated for digital audio. Not all of them are, and if it's not apparent by the part description, contact the vendor to make sure. Next up is the hoods, and you'll always see these very computerized looking gray hoods for these things, which are crap. You don't want them, and the stupid hardware bag comes with it. Get some good metal hoods, not metallicized plastic hoods, but real solid metal hoods. 3 reasons. 1, these are just a lot more sturdy. They're not going to break like the plastic ones. 2, because they're metal, they're going to block a lot of interference and crap that you definitely don't want into an audio signal. And 3, the cable hole is going to be a lot bigger than on the plastic hoods, which you're absolutely going to need because 8-channel multi-channel cable just barely fits in here. Even though this does come with some extras like some extra strain relief rings, you're not going to end up using any of those. And it will come with an extra little hardware bag, and it will come with the 2 screws that you need to actually connect this into what you're plugging it into. Okay, and lastly, if you're doing a panel-based project, you can get these additional hardware kits. Because if you look at this part, you can put this inside this and use it on the end of a cable, or you could actually just mount these into a rack panel, something like that. And what you would do with these is these are the nuts, and I know these are XLRs, just bear with me for a minute. This is the part that would actually get mounted into the panel. So just goes to the front, you get the nuts and the washers to secure it on the back side, and then when you bring your DB-25 connector in, these long screws screw into these panel mounts like turret pieces here. So if you want to do a panel project, make sure you get this panel mount hardware, because this is not typically what comes in a hardware package with something like this. And last but not least, you're going to need some cable. I generally like the Mogami stuff, but I understand it is a little bit expensive for some people. Some other good choices for that. I like the Rapco Horizon multi-channel cable. Getco has a lot of options. And this is the Redco house brand. This is Redco TGS-8. They make it in 4, 8, 12, I think maybe 16 channels. But as far as like the price per foot, it's very affordable. It has a good amount of flexibility to it, and all the specifications look good. So I just have a chunk of this, and this is what we're going to use today for the assembly. Let's start to talk about our prep work. Now, if you've seen any of the videos on my channel, you know I talk about prep work all the time. And the more time you spend on your prep work, the better your results are going to be. And DB-25s are certainly no exception. So let's talk about our cable just a little bit. First thing we're going to do is just like take off a little bit of the over jacket on the outside. And I think I end up being about 1/4 or 1 1/4 inches. And basically you just want to make sure that the thick part of the outer jacket is going to hit these strain relief ribs here on the inside. Make sure that bring this up past that, and then you should have just enough length, probably just a little bit more to reach to the end here. And when you do this, I'm just kind of doing it by eye, right? If I put my connector in and then bring that up to where I want it, I've got probably more than enough length. And I feel like I'd rather cut a little bit too much off and then put it on, and then I can always just trim the end of the wires off if I feel like I have a little bit too much. Like I'm not going to be worried about a quarter of an inch or a 1/2 inch or anything like that. Now, because we're going to have we're going to have 24 individual wires in a very, very small space. And there's two schools of thought on what you're going to do next on these. You can either just take off a small amount, probably like a 1/2 inch like you normally would with the connector, and you can do it that way, or you strip as much of this back as possible, because then that's going to give you the max amount of flexibility on your individual wires, which is going to make it easier to assemble. Now, the people that don't strip that all the way back say, well, you know, you're taking your shield back too far and that's kind of exposed. Honestly, the difference between like a 1/4 inch and 3/4 inch, I don't think is going to make that much of a difference, particularly if you're using the metal connectors. And besides, if you're running balanced, I think the balancing circuit is going to take care of any noise that gets in there anyway. So I'd much rather have a better time of assembling and just make sure that I can get all these individual wires routed where I need them to when it comes time to start soldering these things into the block. So I'm going to strip mine all the way back, and I've started doing it on this one right here. I'm going to bring in this for a little bit of contrast. So let's talk about this multi-channel cable a little bit. When I strip this back, and first things first, there's two main categories I see of this. One, you either have a single color on this PVC over jacket here, and it just has the numbers on there that tells you what the channel is, or the individual channels, this entire thing has a different color to it. There's also one other option where they're all black and they have the numbers on it, but then you can see inside one of the conductors, this one happens to be purple for number 7. That way, if you strip all these off, you still know which channel you're working with because of the color of one of the conductors. Now, this is very important to figure out before you start to strip these back, because if you didn't have individual colors for conductors inside the channels on here and you strip these all the way back, now everything's going to be the same color and you lost your numbers, so you don't know which channel is which. And you're going to have to spend a whole lot of time with the multimeter going between this end and the other end of the cable trying to figure out which channels are. So always make sure, no matter how much this you're going to strip off, that you always are going to know which channel is which. Because if you don't and you get in there, it's a nightmare. Okay, so that's one. Always just have a plan for making sure you know what channel is which. Second thing about this is if you don't work with multi-channel a lot, and not all of them are like this, but this one happens to be, you'll notice we have, of course, our two conductors. One is purple or some other color, and then it looks like the other one is always going to be clear. And then you have this mess of copper, which is your shield, which is pretty standard. And you also have this 4th wire, which is just a bare kind of like nickel-plated wire, and it's like a few thicker pieces of copper than the shield, and it's already pre-twisted for you. So this is basically a drain wire, and this runs the entire length of the cable, and it's in constant contact with the shield. So the thought process is, well, this is, this takes extra time during the install because you need to, twirl everything up or whatever. What you could do is you could always just trim off these shield wires, and then you could just use this drain wire. Now again, like most things, there's two schools of thought on this. One is, well, it's easier to just cut all this stuff off and just use the drain wire. That's why the manufacturer provides it for you. The other school of thought is, why would you ever compromise your shield or your ground? Just take everything, twist it all together, and then solder it together. Normally, I'm like 99% of the time, I'm always twisting everything together because I would rather have that really good shield connection on all of my connectors. It's going to be difficult on these DB-25s, and I've done it before and I know I can do it on these, but that is quite a bit of, once you get all this twisted together and then you're going to pre-tin it, it is quite a bit of mass, and it's just barely going to fit inside that solder cup. So in this particular case, if you think you're going to get better results at the end of the day, if you just trim this excess copper off and just use the drain wire, then that's fine. It's not going to be that big of a deal. Again, if you're running a balanced circuit, you're going to get pretty good noise reduction, and you should basically be, probably interfacing decent gear and all that kind of stuff. So at the end of the day, I don't think it really makes a huge difference, especially if you have relatively short runs. And if you're running hundreds and hundreds of feet of this, then every single thing you can do to your benefit is going to be good. But anyway, I'll leave it up to you. Those are just two schools of thought on it. You do have to do something with this though, because once you strip all 8 of these back, you're going to have a bunch of these shields, and you don't really want them to touch, because if you start to get into like ground loops and that kind of thing between the different individual channels, that's going to be a nightmare inside this DB-25. So we're going to make our own shield or our own over jacket on this. What I'm going to do is I have 2 pieces of heat shrink. I have 1/16 of an inch and have 1/8 inch. What you're going to want to do, and I'm just going to pull this out of the way for right now. I want to make sure they don't touch each other. So I'm going to take the 1/16 and I'm going to slide it over that drain wire. And then I'm going to take the 1/8 and I'm going to slide it over all 3 of them. and that slides down. And just in case there's a little gap at the very bottom where there's just a small amount of shield that's exposed, then the eighth inch heat shrink will come down. It'll cover it all up, and it'll keep the 16th from sliding off the drain wire until I get everything connected. Okay, and that's just going to give you a nice little bundle. It's going to make sure that all of your shields are isolated and they're not going to touch one another. With that being said, I'm going to go ahead and I'm going to prep the rest of this cable. I'm going to cut everything all back. I'm going to make a chart that tells me what all my different colors are, so I know which one is which, so I don't get confused later. And I'm going to go ahead and I'm going to put heat shrink on everything, and then I'll come back after I get all that done. So now I have all my heat shrink in place. I ended up once again using 1/16 shrink on the shield and 1/8 down here at the base, just to cover up that little bit that the 16th inch does not cover at the base of the shield, and just make everything look nice and neat. Couple things here. I'm never particularly precise about how far back I strip. I mean, as we discussed, I definitely want to leave myself as much working room as possible just to make the assembly easier, but you have to be exact with that. And so you usually end up with, like, 8 different lengths of the heat shrink that goes on the shield, which is not that big of a deal. So I just, cut a bunch of lengths and slide it on. If it's a little too short, I'll cut another one. If it's too long, you just trim it down. So I just kind of do that as I go. And you can see that I have the 8 individual colors now, 1 per each individual channel in here. Now, I used white heat shrink on the shields for a reason. One, I just want to get as much color contrast as I can here, but two, it's because white isn't used anywhere in this color scheme. You can see on one side of the conductor, it's all clear. So when you go to assemble, you know that your colored one is going to be your positive, your clear is going to be your negative, and then the white is always going to be a shield. If they had used white somewhere in this color scheme, I wouldn't have used it. I would use black or some other different color. If the low had been black, then I have the white to contrast, but if it had been white, then I would just use black heat shrink. Basically what I'm saying is don't use a color that already exists in there, because again, once you get all this stuff in, you go to assemble, you don't want any confusion as to what wire you're actually grabbing. So from here, I'm just going to go ahead and I'm going to strip the individual ends, and I'm going to tin, and I'm also going to go ahead and get some solder into these cups. Just a little bit though. This is not like building an XLR where you can really just put a whole bunch of solder in and fill that whole cup up. There's not a whole lot of extra room once you get the wire in there. There's not a lot of extra room for solder. So when I tin, I'm going to be very, very conservative and just use a little bit. So like I said, I'm going to strip this down, get everything tinned up, and then we'll start the assembly. Our cable is now all prepped. Everything's the way I want it. Everything is stripped and everything is tinned. In addition to that, I printed out my color code, which tells me which color corresponds to which channel, so I don't get lost. And I always print these out because my handwriting sucks. So I have that. So apparently we're ready to go, right? Except for just one more thing. Where are we going to solder all these wires to? So for that, what I say all the time, and you definitely want to do it this time, you need to read the manual. Now, there is no real die-hard, set-fast rules for how to wire up DB-25s. I mean, it's not like, XLRs where it's like a pin 2 versus pin 3 hot kind of thing. It's like we all know that pin 3 is hot. Just kidding. Seriously though, pin 2 is hot. Don't do pin 3. So basically, whenever you wire these up, especially if you're going to wire into a particular piece of gear, you absolutely should find the required pinout in the manual. Now this is for a Motu sound card, which is something I wired up for a customer a couple weeks ago. And this is about as close to a standard as you're going to get. And you can see here, the fine print, it says follow the Panasonic Tascam AES/59 standard, which is pretty common. And basically all it does, it tells you out of the 25 pins, we're going to use 24 of them. And it basically just tells you, well, channel 8 is on these 3, channel 7, blah, blah, and it goes all the way down. Again, very helpful to find this information, get it printed out, and have it on your bench when you start this process, and you just have something to reference to and you don't have to second guess. The other thing about this is make sure when you put your connector into your vise that you have the pin orientation correct. It's a little bit difficult to see in here, but you can see they start with pin 1 in the upper right hand corner and pin 25 is in the lower left. When you put your connector in the vise, make sure it's correct, because if you do this backwards, you're going to be very upset with yourself. So as you can see here, I've got mine in my vise. What I've actually done is I'm going to solder onto the male connector. I actually have a female connector plugged in, and I have them, just so we're sure what we're looking at here. Okay, here's the male, here's the female. going to take a female, I'm going to plug it into the male, and then this is going to go into my vise. And why do I do this? Because the female is going to help to act as a heat sink for the male. Now, I've talked a little bit about soldering tip temperature and stuff before, and like the differences between PCB and like really small components and that kind of thing, and how I usually have my tip cranked up pretty hot because I do a lot of cables and I'm soldering onto big hunks of metal, and you're not really damaging, and there's a lot of mass that's going to soak up a lot of heat. Not so much on this. And guaranteed, if you put too much heat into one of these pins, it will soften this block that contains all the pins, and that pin will slide. Once that pin slides, it will never be secure again. At least I won't trust it again. So I want to make sure that my tip temperature is under control and that I'm going to heat sink in any way that I can. And I find just putting the female in there just gives it basically doubles the mass, and it definitely will pull some of that heat away from this side of the connector. And I probably I'm going to start off my tip temperature. What am I? I'm at 70, well, 700. So where I'm normally probably up around 750, 800. So as I said, I already tinned my wires, and I did tin these solder pockets here, and I left one open just as an example. I want to show you what I'm going for here. When I stripped the wires, I'm basically I want to make sure that I stripped enough, the conductor here, where the length of the wire is basically equal to the length of the soldering cup, plus maybe like a 1/16 of an inch, because it doesn't just stop flat here, there's actually a little bit of a hole. So when I soldered, basically just going to, when I tinned, soldering iron there, a little bit of heat going, and I just put a drop on. What I tried to do on most of these, I did pretty good. The solder is only on the front half of the cup, and I left just a little pocket at the back of the cup. That's going to make it a little bit easier to assemble, because when I come along with these wires and I put it in there, I'm going to be able to take the tip and I'm just going to stick it into that little pocket, and that's going to help hold it there for me. And all I have to do is come along with the iron. I'm going to heat it up, and it's basically going to take that solder that I tinned on the wire and the solder that I put in the cup. That's all going to melt together, and that should be all the solder I'm going to need. I don't really plan on adding any additional solder to these as I go through the assembly process. Okay, two more quick things before I do this. Normally, when I'm soldering, you always want to take the tip of the soldering iron and you want to drag it off of your part. That's going to be a little bit difficult with something this small, and it is very possible, especially if you put a lot of solder into your solder cups, that you can actually drag solder from one cup into another, shorting those two cups out. That's obviously not a good thing. You don't want to do that. So I'm going to pull up and just going to twist the iron a little bit as I pull up just to try to motivate that solder to stay in the cup and not lift up into a little mountain with the tip. And second thing is, I'll probably just do this with my fingers as I feed these individual wires and hold them in there. The wire is going to get a little bit hot. You're going to feel that heat through the insulation. If that's uncomfortable for you, you can always use some needle nose pliers or something like that, or even like a little heatsink clip, or just whatever you need. But I'm just going to see how this goes. I'm going to pull my fan on. I'm definitely going to high speed this, but then I'm just going to go across. I'm just going to start all the way across the top, then I'm going to flip it, they're going to go all the way across the bottom. Okay, let's do it. And that's the assembly. If I check the recording here, I think it took me 22 minutes to do it. I'm not bragging, I'm not saying that's fast or slow, that's just how long it took me. I tend to just go slow and take my time with these. A couple things to point out. One, earlier when I talked about the shields and the drain wire, I said there's the two schools of thought where one, you could either just use the drain wire or you could take the drain wire and wrap it up with the shield. I think if I had to do these again, I would probably just use the drain wire and not use that extra shield, because I have a couple of these and they're literally just practically popping out of the solder cups. Didn't look like anything shorted in there, and I can test this with a multimeter to make sure, but I think it's just a little bit too much material to go in that solder cup. The last time I built one of these, I didn't have a drain wire, so I didn't have the extra mass to worry about, so it wasn't an issue. But this, I actually had not built one using this wire yet. Not saying it's bad wire, I'm just saying I wouldn't use the shield. I'd probably just stick with the drain wire. Two, you did see me go in there with the needle nose pliers a couple times, just to grab a couple wires and pull them from the other side, whatever. And I typically prefer to use my fingers, just because if you do get the soldering iron there just a little too long and you use the needle nose pliers, you do tend to get a little bit more shrink back, just because it's very easy to apply just a little bit too much force to the jacket on the wire when it's hot like that, and to pull it back or deform it in some way. But there were one or two wires in there where I just couldn't get them where I wanted with my fingers, especially towards the end. When you flip it over, everything starts to get a little bit more difficult. So again, I always try to use my fingers unless I just can't get the wire where I want to, and then I'll go to the needle nose pliers. But then I just always really careful when I do it. Three, you'll notice a lot of times I'll take the entire wire assembly and I'm just pushing it in, and I'm just I'm bending all the wires so I can get a wire up to where I need it. Don't think that this is fragile, okay? You can manipulate this however you need to. If you need to twist it around or push it in or pull it out or whatever, do whatever you need to do to try to get the straightest path possible for all of the wires. Even if you just have, like, once you get one or two wires on there, even just the solder holding those one or two wires, it's going to hold this whole cable. It's not that big a deal. And it's not like I have this end of the cable is off on the floor. It's actually just sitting here on the bench. And if I had a long piece of cable and it was too long to put on the bench, I would normally just use a clamp, and I would just clamp part of the wire to the edge of the bench, just in case you ever kicked it or anything like that. You just want to make sure that none of that, you don't get too much weight pulling off this while you're working on it. You want it to be flexible and easy to work with. But again, if you have to just, shift everything to one side or shift everything to that way, do whatever you have to do to get everything assembled. Yeah, here we go. You can see there's a slot right about here, where that's just going to fit in there. There is no right side up, right side down. So it turns out that my strip lengths turn out to be pretty accurate. You can see the edge of my PVC jacket right here comes up. Again, I have these two divots here. That's going to act as my strain relief. The edge of my PVC came up, and I can just push this in just a little bit, which is fine. And I've got both of those ridges are going to grab onto my cable. Flip this around, sandwich it together. That feels pretty snug as it is. If your wire's too big, then you may just have to try to find another source for your D-sub connectors. If it's too small, you could always put a layer or even 2 layers of heat shrink on there if you need to. And there you have it, your DB-25 fully assembled. Of course, you're only halfway done. Now you have the other end of the wire, but this is really the beauty of DIY, especially on something like this, because when you work with this many channels, I mean, typically when you buy these, you get them and it's, the D-sub to 8 XLRs or 8 1/4-inch TRS. But who's to say that's really what you want? Maybe you want half and half, you want half XLR, you want half TRS, you want maybe some feet, maybe you were splitting this between inputs and outputs, or again, maybe you're just using some completely non-standard one-off custom project and there's 25 pins in there. Who's to say you couldn't use 12 channels of unbalanced signals? Assuming you could actually find a cable where you can get 12 channels of unbalanced in there. But you know what I'm saying, you can basically do this however you want. So again, it's a bit time consuming. You have to make sure you get the right parts. It takes a little bit of skill and practice, but once you try to tackle something like this for the first time, it can be very rewarding and can open up all kinds of custom cabling possibilities to you. So I hope you learned something. If you like this video, please hit that like button, hit that subscribe button. What do you want to see next? Any particular connector you want to see? Leave me a comment down below. Tell me if you've done your own projects. Let me know what you want to see next here on the channel. Thanks as always for watching. I'll get you next time.